Today we are going to discuss electromagnetic induction. In the previous class we have seen that in a magnetic field a current produces deflection in the wire. Now the question arises, is its inversion possible? Can a deflection produce electric current in the wire? This thought leads to the discovery of electromagnetic induction. In 1831, Sir Michael Faraday discovered electromagnetic induction, in which he saw that when a coil is deflected in a magnetic field, a current is produced in the coil. Okay. Now watch the following experiment that will help you to understand the concept of electromagnetic induction. Okay. So watch the video first.
In 1831, Michael Faraday in London and Joseph Henry in New York independently discovered electromagnetic induction. I am going to demonstrate electromagnetic induction with an experiment similar to the one that Michael Faraday performed. I have an ammeter here and I have 3 coils. I have a coil with 1 loop, 10 loops, and 100 loops. I also have a bar magnet, and I will start by connecting the single loop coil to the ammeter. I now have the single loop coil connected to the ammeter, and I'm going to move the bar magnet into and out of the coil. And if you watch very closely, you can see a slight deflection of the ammeter needle. Okay, so now let me connect the 10 loop coil. And then I'm going to do the same thing. I'm going to move the bar magnet in and out of the coil. Now you can see more movement of the needle. In fact, if I go very slowly, you see just a little bit of a deflection. And if I go quickly, you see a greater amount of deflection. Also, as the magnet is going in, the needle deflects to the right. And as I pull the magnet out, it deflects to the left. But when the magnet isn't moving, there's no deflection, indicating no current flowing. Okay, so when the magnetic field is changing going into the coil, there's a positive current flowing. When it's changing coming out of the coil, there's a negative current flowing. And now let me connect the 100 loop coil. And I'll start by moving the magnet in very slowly. You see a deflection to the right, pull it out to the left. And if I go in quickly, you see a much greater deflection. Okay, so the rate of change of the magnetic field affects the current also.
In the experiment, we see that when the magnet moves towards the coil, the galvanometer is deflected in one direction. Okay, and when the magnet moves away from the coil, the galvanometer deflects in opposite direction. Okay, and this is due to induction. The current is induced due to motion of the magnet, and this induction also possible when the magnet is at rest and coil is moving. Okay, here the magnet is at rest and coil is moving towards the magnet. Then there will be a deflection, and when the coil is moving away from the magnet, you will see the deflection in opposite direction. Okay, so one thing is clear, that for induction one must have in motion either coil or the magnet. Okay.